So what we're doing here is we are having a look at how we can go about going through these success criteria using CAS, and so this should hopefully keep you in good stead for the SAC. So the first video that we're going to, or the first function we're going to have a look at is question 1 from exercise 13.6. That's that thing with the weird shape. So what we're going to do is we're going to enter in that equation. So because question 1 from 13.6, so I'm going to say define a of x because it's an area. Area of x equals 150x minus, open a bracket, 2 times the square root of 2 plus 1, close the brackets, times x to the power of 2. That's what we've got there. So that's what it's telling us it is. Now let's just check to make sure it's been entered incorrectly. 150x minus 2 times the square root of 2 plus 1 times x squared. Okay, so that's what we've got there. So let's have a look at the success criteria. So we've got to be able to evaluate a function at an x value. So that is just, we're just going to substitute an x value. So we're seeing where this equals. So I'm going to say a of 1. That's our value for a of 1. A of 12. We've got that value there. So all we're doing is we're just substituting a value into the function there. Okay, now it's asking us to find the determine average rate of change between 2 points within a function. So here's our 2 points. We want to find the average rate of change between x equals 12 and x equals 1. So what we do is we say we do our rise over run. So rise over run, and our rise is our 2 y values, and our run is our 2 x values. So what we do is we say a of 12 minus a of 1. And we are going to divide that by, let's put in my brackets first. So we're going to have that. So our rise is a of 12 minus a of 1. So that's our 2 y values. We're going to have 12 minus 1. And then from there, we will work that out. And that has not worked at all. So we're going to do that again. Rise, run, divide a of 12 minus a of 1 over 12 minus 1, and that's better. That's how it should look. So that's what I'm going to end up with it. So that's our average rate of change between 1 and 12. We've got that. So the next one, so we found the evaluated function, determine the average rate of change. That's our average rate of change. Determine the derivative of the function. So what we can do, to find the derivative of this, we'll go to menu, calculus, derivative. And we're going to say ddx of ax. And there we have it. So there's our derivative function. Now, from there, we want to find a derivative at a point. That's the next thing we're going to say. So we want to find the derivative at x equals 1. Well, we just take our value there, and now we change that x with 1. And that's what we're given there. We should be able to go here and choose our value here. Oh, it didn't work. So no, because it's taking a as 1 first. So that's what we could do. So we'd say find our derivative. We then substitute x for whatever our derivative is. So say we're looking at derivative when x equals 10, we end up with that. We can also go to menu, calculus, derivative at a point. We're looking at x of 1, and then we type in a of x. And we end up with what we had before. So that's that option. That's what we can do for that, to find the derivative at a point. Let's see. Now the next thing we're going to do, we're going to have a look at determining the domain of a function. So for this, basically we want real values of x. So let's see if we can sketch that thing. A of x. And there we go. It's a straight line going up and then coming back down. That's a bit chaotic. So a bit hard to do there. So I'm going to say we're going to solve this 0, because I know that we can't have any area that's less than 0. So this tells me that our value is that our domain goes from 0 to this number here, 150 times that over 7. So that is how we go about finding the domain. So then we can redefine that function. So we'll say define given, and we put in these values here. 0 is less than, 0 is less than x less than 150 divided by 7 times 2 root 2 minus 1. So that's the way we'd say that. And the reason for that is because that's where it ends up being 0. So now we've got our function defined over that domain. And then if we want to sketch that, let's go back to here. We'd say sketch a of x and it'll sketch it for us. So we should be coming through at about there. Okay, I think that's it for now. So we've covered function, determine the evaluated function next value, average rate of change. We've seen how to find the derivative. Write an equation practical concepts, haven't got that yet. Determine the domain of a function, yes. Find the derivative of a point. Determine the equation of a tangent at a point of a function. Determine the equation of a line perpendicular to a tangent. We haven't done that yet. We've done can sketch lines. A minimum maximum, we haven't quite done that yet, but we'll where it's increasing, decreasing, and things like that. So I'm going to stop this video and we're going to have a look at the next one as well.